Alright, grade 12s today we're going to be looking at the distribution of p hat. And I want you to consider a bag of 20 balls. And inside this bag we've got 5 red balls and 15 blue balls. In other words, our population size n is 20. Now we're interested in the red balls, okay? So we're interested in the red balls. Okay, that means that our population parameter for the proportion is p, and that's a quarter. So we have 5 red balls, so 5 over 20 is a quarter. So normally we wouldn't know the population parameter, so we would have to sample from our population to determine the sample statistic. So if we have a look at figure 2, can you see that some of it has been circled? And in that sample of 5, we've only got 1 red ball. So our sample proportion is 1/5. Okay, so we've got 1 red ball out of the 5 that we took out of our bag. Let's take another sample. So in this sample, here it is, circled over here, we have 2 red balls. So this sample proportion is now 2/5. Okay, now we take another sample. Every time we put the balls back, and here you can see there aren't any red balls, so our sample proportion is 0. Now, it might seem that using a sample doesn't give you a good estimate about our population, but as we get a larger and larger sample size, the closer we will be getting to the actual population proportion. Okay, so suppose we repeated this sampling experiment of 5 balls from 20 many times, and consider the random variable x being the number of red balls and p hat being the proportion of red balls, where p hat is x over n. Okay, now remember with our combinations we can count the number of different ways we can select x objects from n objects. Okay, and the following table shows you the probability distribution of x and p hat. So over here is how many red balls you've selected from 5. You can see you can either have 0 or 1, 2, 3, 4, and 5. We've gone through our sample proportion. So this is our sample proportion. Okay, so we can either have 1 red ball, 2 red balls, 3, 4, or 5. Okay, but we're selecting them out of 20 balls. Okay, now we know here that we've got 5 red and 15 blue. Remember, and is always multiplying in our probability. Okay, so we know that if we have a sample 0 sample proportion, from 5 red we've selected 0, but that means all 5 of our balls that we selected would have had to be blue. So 0 plus 5 gives me 5. Okay, and that means I've got 3,003 different ways that I can select 0 red balls and 5 blue balls. And that can go through the whole process. Every single time there would be 1 red ball, 4 blue balls, 2 red, 3 blue, 3 red, 2 blue, and so on, always adding to 5. So the total number of ways that I can select 5 balls out of 20 balls would be 15,504. And to work out my relative frequency of that, I would just have my 3,003 over my total, so 15,504, and that gives me the 0.194. Okay, now we can create a distribution for this, and we can call that a sampling distribution. And we could just put our sample proportion in 1/5, 2/5, 3/5, 4/5, and 1. And we can use our relative frequency as our probability. So 0.194. 0.440, 0.293, 0.005, and 6.45 times 10 to to the negative 5. All right. And we can find our expected value for that. And our expected value is also going to be our mean. Okay, so remember that our expected value of p hat is the same as our mean. And we can find that by saying that's the sum of p hat multiplied by my probability of p hat equaling p hat. And that would be 0 times 0.0114 plus a fifth times 0.440 plus 2/5 times 0.440 plus 3/5 times 0.068 plus 4/5 times 0.005 plus 6.45 times 10 to the negative 5 times 1, obviously, and that's going to be equal to 0.25.